the velocity potential function is given by phi is equal to 4 into x square minus y square. Calculate the velocity components at the point 2, 3. So here given velocity potential function. So generally velocity potential function is denoted by phi. Velocity potential function is denoted by phi. Okay. So here phi is equal to 4 into x square minus y square. Okay, now so this is velocity potential function in 2 dimensions. Okay, so x and y is given. Next we have to find velocity components at the point 2, 3. We have to find velocity components at the point 2, 3. 2, 3. Okay, now so here phi is called velocity potential function. Phi, velocity potential function. Okay, now so velocity components means we have to find u comma v. Okay, so u is equal to how much and v is equal to how much at point 2, 3. Now what is the relationship between velocity potential function and velocities in x and y directions? See, so here u is velocity in x direction and v is velocity component in y direction. So u means velocity component in x direction and v means velocity component in y direction. So for velocity potential function, we know that velocity in x direction in terms of velocity potential function phi, u is equal to minus dou phi by dou x and v is equal to v small v and v is equal to minus dou phi by dou y. And similarly if you want velocity in z direction, velocity component in z direction, minus dou phi by dou z. Okay, anyhow we have only velocity components in x and y direction, so he given only 2 dimensions x and y. Okay, now first of all find velocity components in x and y direction, u and v. So before that find dou pi by dou x and dou phi by dou y. So dou phi by dou x means partial differentiation of pi, partial derivative of phi with respect to x. Okay, now dou by dou x of what is pi? 4 into x square minus y square. X square minus y square. Here 4 is constant. Take out 4 out of partial differentiation and dou phi by dou x into x square minus y square. See, here we are doing partial differentiation. In partial differentiation, we generally observe independent variable. Here independent variable is x. Independent variable is x. Since we are doing with respect to x, since we are doing partial differentiation with respect to x, and the remaining all the terms are constants. Okay, see, we are doing with respect to x, so x square is variable term. Now y square becomes constant term. Okay, 4 into dou by dou x of x square 2x, dou by dou x of constant y square 0. Okay, now we assume y as a constant, derivative of constant is 0, so 4 into 2 8, so 8x. Similarly dou phi by dou y, dou phi by dou y. Now we are doing partial differentiation with respect to y, so dou by dou y of what is phi? Phi means again 4 into x square minus y square, 4 into x square minus y square. Again here we are doing partial differentiation or finding partial derivative with respect to y. So here x is constant since we are doing with respect to y, and y square is variable term. Now dou y by, this is 4 constant, dou by dou y of x square constant term. Here x is constant term because we are doing with respect to y, so 0 minus dou by dou y of y square 2y. Okay, so 4 into minus 2y minus 8y. Therefore dou phi by dou y is equal to minus 8y and dou phi by dou x is equal to 8x. Okay, now use these two formulas to find velocity components in x and y direction at point 2, 3. Now velocity components in x and y direction, u is equal to minus dou phi by dou x Now u is equal to minus dou phi by dou x is equal to what? Dou phi by dou x equal to 8x. So minus 8x. U is equal to minus 8x. Similarly, v is equal to velocity component in y direction. Okay, minus dou phi by dou y. So minus of dou phi by dou y minus 8y. Minus 8y. So minus into minus plus. You will get plus 8y. Okay. So u is equal to minus 8x, v is equal to plus 8y. Now we have to find velocity components at the point 2, 3. So 2, 3 means at point 2, 3 means x is equal to 2. Here x is equal to 2 and y is equal to 3. X is equal to 2 and y is equal to 3. Okay. So put x is equal to 2. Then u is equal to velocity component at point 2, 3 is minus 8 into 2. So minus 16 units. Okay. Now velocity component in y direction, v is equal to plus 8y. Now 8 into 3, y value 3. So put y is equal to 3 and 8 into 3, 24. 24 units. Therefore velocity components u and v are minus 16 units and 24 units.